Hello guys, and welcome to a new video in physics. In this video we will complete lesson 1, velocity time graphs. In a velocity time graph, velocity is plotted on the vertical axis and time is plotted on the horizontal axis. So in the coordinate system, just like this, the velocity we should write it just like here in the y-axis or the vertical axis, and the time we should write it here in the x-axis or the horizontal axis. You can determine the acceleration from a velocity time graph by calculating the slope. When we calculate the slope for a coordinate system for the velocity time graph, that means we are calculating the acceleration. The average acceleration of an object is the change in velocity during some measurable time interval divided by the time interval. The change in velocity at an instant of time is called instantaneous acceleration. And this is the definition of instantaneous acceleration, is the change in velocity at an instant of time. The instantaneous acceleration of an object can be found by drawing a tangent line on the velocity time graph at the point of time in which you are interested. The slope of this line is equal to the instantaneous acceleration. A curved line on a velocity time graph shows that the acceleration is changing. The slope indicates that the average acceleration during a time interval that you choose. So for example, here we have a coordinate system and we have the movement in a curved line. So if we need to calculate the acceleration, so the slope will indicate the average acceleration. We should choose any 2 points as we learned. And after that we calculated, we can find the slope, which is represent the acceleration. Average acceleration is defined as the change in velocity divided by the time it takes to make that change. The equation for average acceleration is shown below. A equal to delta V over delta T. Delta V, that means V final minus V initial, and delta T, that means T final minus T initial, and this is the law of the acceleration. Here we have the first problem about the acceleration. So here we have a question which is, what is the object average acceleration between 20 and 40 seconds? Here we have a coordinate system and we need to find the acceleration between 20 and 40 seconds. So from the figure here, we can write the known and the unknown in this question. So we have here the second 20 second. This is 20 second. So the velocity is 4 meter per second. This is the velocity for 20 second, 4 meter per second. And 40 second, the velocity in 40 seconds is 0. So the velocity for 40 is equal to 0 meter per second. Delta t, we can find delta t by subtracting 40 minus 20. 40 minus 20 is equal to 20 seconds. And we need to find the acceleration. So A equal to, sorry, here we should have delta. Here is delta V. And here also we have delta t. Delta t. So delta V over delta t equal to, that means V final minus V initial. V final that equal to 0 minus V initial, which is 4 meter per second. Here we have the final velocity 40 second, and the first velocity, which is equal to 4 meter per second. So 0 minus 4 meter per second over 20 seconds. The final result should be minus 0.2 meter per second square. This is the unit of acceleration. Here we have also another question. On a test track, a professional driver performs a 0 to 60 test. That is, she starts the car at rest and accelerates as quickly as possible to 60 miles per hour, which is equal to 26.8 meter per second. If the small sedan she is testing has a 0 to 60 time of 8.5 seconds, what is the car's average acceleration? So as we learned in the beginning, we should write the noun and the unknown in this question. The noun that we have here, the first velocity, it's from 0 to uh, 60 mile per hour. Of course, we should change the miles per hour to the meter per second, which is equal to 26.8. So the first velocity equal to 0. The final velocity at 26.8. Sorry for that. It's 26.8 meter per second. And delta t, we have it, which is equal to 8.5 seconds. After that, we should write our law, which is A equal to delta V over delta T. Delta V, that's equal to 26.8 meter per second minus 0, which is V final minus V initial. So 26.8 minus 0 over 8.5. The final result will be 3.15 meter per second square, which is the unit of acceleration. Now we have practice problems. In this practice problems, we will solve just question number 2. So question number 2, use the velocity time graph of the toy train in figure 9 to answer these questions. This is figure 9. The first question is, when is the train's speed constant? So from the figure 9, we can say that we can see, the constant velocity, it's just here. So the answer is from 5 seconds to 15 seconds. We can say it's from 5. We can say it's from 5 seconds to 15 seconds. Question number 2. During which time interval is the train's acceleration is positive? We can see here the positive is from 0 until 5 seconds. So we can say from 0 seconds to 5 seconds. Question number 3. When is the train's acceleration most negative? From the figure, we can see that we have here a negative from 15 to 20 seconds. Here we have a negative. Also, we have a negative movement from 20 to 40. But in the question, he asks me what is the most negative. So the most negative, it should be from 15 to 20 seconds, because here we have a drop. But from 20 to 40 we have a curved line, and here we have a drop in movement. So we can say it's from 15 second to 20. So the answer, it should be from 15 second to 20 seconds. And this is the solution for question number 2. Now we have example problem number 2 in the book, which is describe a ball's motion as it rolls up a slanted driveway. It starts at 2.50 meter per second, slows down for 5 seconds, stops for an instant, and then rolls back down. The positive direction is chosen to be up the driveway. The origin is where the motion begins. What are the sign and magnitude of the ball's acceleration as it rolls up the driveway? Here we have the ball and it rolls up a slanted driveway. So in the beginning we should write the noun and the unknown in this question. So from the question, here we have it starts at 2.50 meter per second, which is the first velocity, or v initial. So v initial equal to 2.50 meter per second. Slow down for slow down for 5 seconds. So here we have the time, which is 5 seconds. Stops for an instant, because here we have a stop, so the final velocity, it should be 0. And of course we need to calculate the acceleration. So in the beginning we will write the law, which is acceleration a equal to delta v over delta t. 0 minus 2.50 meter per second, that's equal to minus 2.50 meter per second, divided by the time, which is equal to 5 seconds. So the final result, it should be minus 0.5 meter per second square. Or we can say it's 0.5 meter per second square down the driveway. And this is the solution for the example problem number 2. Also here we have practice problems number 5. So in question number 5, a race car's forward velocity increases from 4 meter per second to 36 meter per second over a 4-second time interval. What is its average acceleration? So as we learned in the beginning, we should write the noun and the unknown in this question. So from question, this is for question number 5. So we have here the first velocity and the second velocity, or the final velocity. So v initial equal to 4 meter per second. And final velocity, we have it, which is equal to 36 meter per second. And also we have the time interval, delta t, which is equal to 4 seconds. Now to calculate the acceleration, we will write our law. I will write it down here. A equal to delta v over delta t. So delta v, that means v final minus v initial, over delta t, which is t final minus t initial. V final, we have it, which is 36 minus v initial, which is 4, over delta t, we have a time interval which is equal to 4. Now the acceleration is equal to 36 minus 4, that's equal to 32 over 4. And the acceleration is equal to positive 8 meter per second square. This is the final result for the acceleration. And you can notice that all the question we can solve it in the same way. So I will not find the solution for the other questions because it's the same law, and in the same way we can find the acceleration. In the end of the lesson, here we have a quiz. We have 5 questions, so please solve it and send it to me. The first one is in a particle model diagram. How do you identify non-uniform motion? Here we have 4 answers. Choose one of them. The second question is if a car's acceleration is in the same direction as its velocity, what happens to the car's speed? Which one is the right one? Question number 3. Which line or lines on the graph represent positive acceleration if east is the positive direction? Which one of the lines represent positive acceleration from this graph? Using the graph, determine the average acceleration between 2 seconds and 4 seconds. Here we have a graph from these 2 points. This is the first one, and here we have the second one. Determine the average acceleration. Which one is the right one? Question number 5, the last question, is you can determine which factor of an object in motion by determining the slope of a tangent line on the velocity time graph at point in which you are interested. So, which one is the correct one? Please solve it and send it to me. And until here, we reach to the end of our lesson. See you soon in another one, inshallah.